Today our new topic is on coastal littoral processes. Right now let's turn to coastal formation as a result of the littoral process. Earlier we have talked about a longshore transport which happens due to the longshore current. If the coastline is relatively straight and uninterrupted, then the longshore transport or beach drift will continue to move in the down coast direction. However, things changes a bit when it arrives at a headland like this, whereby the material no longer is able to follow the coastline, but as it is being washed by the longshore current due to the wave action, it will be deposited to form a spit on the down coast side of the headland. So this spit is a result of the accretion, the deposition of the material that has been eroded from here, and so it will continue to grow over time. It may tend to bend inwards under wind action or tidal current. It may or may not be able to build itself across a river where there is substantial outflow, and that will maintain a channel here for the river water to enter into the sea. However, due to the sheltering effect, the area here will become calm and sheltered, and as a result of that, sediment from the river may start to accumulate in this region and making this area shallower and shallower over time, and eventually evolve into what we call a salt marsh. This figure here shows example of a spit observed near Chukai on Google Earth. Based on the observation, we can deduce that the longshore transport is moving in the left direction, and the sediment source may have come from the right hand side here, and it travels across the headland and begins to form a spit over time that has grown to be quite long, and also it curls inward, possibly due to the wind action. We can see additional formation over here, which may arise due to the sheltering effect of the spit, causing this entire area here to be relatively calm and allow sediment to be deposited. On this slide we can see Kuala Pahang and the spit that has formed over time south of the river mouth. So it is very likely that sediment flow from the northern coastline as well as sediment discharge from the river has partly been washed down this headland structure, and so the sediment are not able to flow along the shoreline over here, but has formed a spit which over time has been overgrown with seemingly very dense vegetation. If the flow from the water body is not strong enough, then the longshore transport can cause the spit to grow and eventually develop itself across the entire opening, so that right now it is known as a bar, which separates the water in the sea and the water body on the land side, which may be a lagoon or it may be from a river. This picture here shows one example, of how a sandbar separated the sea and the lagoon. These two figures over here shows the evolution of the spit. As we can see in this case, the spit has grown significantly across the entire river mouth because of the large discharge from the river. The spit was eventually broken off, even though it is still in the middle of the river mouth. So it has obstructed partially the river mouth, but then the bar in this case has stayed. The relief allows the river discharge to continue to flow to the sea. This figure here shows a coastal bar which is formed at the river mouth of Sungai Surah, just next to UiTM Dungun. If you examine the area, you will find that this is a relatively long straight coastline. The result of the beach drift has brought sediment to this river mouth, and we have a headland over here, whereby in this case the sediments are not able to go further southwards, but they are being deposited at the river mouth, and as a result of that obstructed the outflow of Sungai Surah, which in the first place is not very large. So it has been reported that this coastal bar causes Sungai Surah to overflow and causes flooding upstream in its catchment. So as a result of that, an engineering work was proposed to upgrade this river mouth. A dam was constructed over here so that during low flow condition there's no mixing between the water from the river and the water in the sea, but when there is high flow, then the dam open up to flush out the water from Sungai Surah so that there is no flooding in its upstream catchment. This is another location showing a coastal bar which separates the sea from the lagoon near Kemaman. We can see the lagoon over here on the satellite image as well as the digitized Google map. The lagoon is connected to the sea at this location over here, but clearly what we can see from the Google Earth image is that there is a coastal bar which has blocked the exchange between the lagoon and the sea, although this has not been correctly digitized by the Google map, which is understandable because the coastal formation itself may not be a permanent feature and it can be evolving over time, whether in a short-term scale such as annually, whereby during certain season of the year it could be that this water body here may have enough discharge to wash itself out and opening up into the sea, whereas in other season of the year it may be blocked by the coastal bar formation. The formation of the barrier island is closely related to the spit, but it is an entirely different process. When spits are already formed in the coastal area, if there is sea level rise, which in this case can only happen over a long time period, the flooding inundated the low area of the land, and as a result of that causes the mainland to be separated from the spit, and that is where this remaining spit formation is now known as the Barrier Island. This figure over here shows example of Barrier Island in Kelantan coastline south of Kuala Besut. We notice that in this case the shoreline is separated from the mainland by the lagoon, most likely due to flooding as a result of sea level rise over long time period. The formation itself looks quite like a spit, but if we examine the coastline, this is a relatively long straight coastline, so that makes this formation less likely to be a spit, but part of the original coastline which has been separated from the mainland. This is another Google Earth picture showing the Pahang coastline south of Pekan. We have a formation over here. Is it a spit or is it a barrier island? We shall leave this for our online discussion. As mentioned previously, tide can also play a role in the coastal littoral transport. The result of the flood and ebb current of tide can move the sediment, whether sand or mud, and deposit them in the shoaling area, usually at the river mouth, forming a tidal delta, or even in a tidal inlet like this. Specifically in this case, a tidal inlet between two barrier islands. So the ebb and flow of the tide causes the sediment to be deposited on the lee side, here forming a small tidal delta. This figure here shows a tidal delta near Kerteh, whereby this is the tidal inlet. We can distinguish from the picture that there is rich sediment material in this region, and also that the tidal delta is relatively shallow, suggesting that the flood and ebb tide causes the sediment to be deposited in this region, forming this tidal delta. Sea stack is defined as a geological landform which consists of a steep and often near vertical column of rock in the coastal area, formed typically by wave erosion. This is a famous sea stack in Kuching National Park, whereby the formation looks like a cobra head. Meanwhile, Tombolo is a deposition of a landform in which an island is attached to the mainland by a spit or bar. Example here, this is an island. We have a sandy formation here which attach the island to the mainland, and that is the Tombolo. So how does this Tombolo forms? Usually what happens is that the island has created a sheltered region here on the lee side, which is relatively protected from wave action. As a result of that, littoral drift that brings sediment to this area will be inclined to be deposited, and so over time the sediment deposit will grow outwards from the mainland and eventually possibly becomes attached to the island itself, and that is the Tombolo.